Hello everybody and welcome to Handmade Hero, the show where we code a complete game live on stream. We nominally, and I guess we don't really know because we haven't had any particular stress testing of it yet, but we actually implemented our own PNG reader over the past couple episodes, and it appears to be functional, at least for the PNGs that we have tested so far, which means we can proceed to step 2 of our plan for world domination, which is trying to put some art into Handmade Hero. And actually, as part of that process, in addition to putting art in Handmade Hero, making it be able to have something in the way of an easy-to-use system so that an artist who was running the game, who wanted to replace an art asset in the game, could do so without having to know how to program or anything like that. Something that can work in this way. So that's our goal for the next couple episodes, is to work towards that. We've put ourselves in a situation that none of the architecture in our game really will have to change because we already support on-demand streaming of assets. And when you support on-demand streaming of assets, it means that you could just for free replace an asset, because since all of the game already has to be written in a manner that makes it so that the game doesn't know whether the asset is present or not, replacing the asset with a new asset is fairly trivial. Now, there are some things that we may have to work on that aren't streamed. Like, there may be some things that we count on being consistent that now won't be consistent, but we've already done the bulk of the work, which is to say that not knowing that an asset is always there is really the hard part of hot loading, and we've already done that. So we're going to have a much easier time of this than you would have if you were retrofitting hot loading into a game that had never considered the possibility that an art asset wasn't present, because, you know, that's the part that usually trips you up, and we won't have that. So that's the good news. The bad news is, well, we probably want to do some architectural changes anyway, because now that we know that we want to support hardware rendering, because we have a hardware renderer now, we probably want to take this opportunity to also enforce some kind of a rigid texture size, so that we can use texture arrays and avoid all of the draw call restarts that we currently have to do because we allow textures to be arbitrarily sized. So we may end up doing some architectural changes anyway, but again, those should probably be much more limited than they would have had to have been otherwise had we not done a streaming asset system. So streaming asset system kind of coming into play here. I noticed some people on the chat saying that they are mesmerized by the bobbing orphan on the webpage. Yes, that is kind of a fun little animation we made for the Handmade Hero purchase badge. We thought it would be fun if our websites all had sort of animated badges instead of the kind of lame static badges, and we just had fun making them. So Anna drew this one, and it's just kind of fun. We actually have those for the Handmade Fund as well now. There's a little one for that as well. So you can get your pick of little animated icon there. Yeah, and if you haven't ever used our website now, our new website's pretty easy to use. There's just a button bar at the top. You can get to whatever you want on the Handmade Hero stuff. And if you click on the main hero head, you can actually get all of our websites. You can jump directly to them, actually. So you can jump to 1935 if you want to, which will be updating actually in a couple months with some screenshots and trailers and stuff. So that'll be useful to know. We've got the comic that Anna's working on right now, which should come out soon as well. So we got those. We got Handmade Hero. We got our main site, which you can always go back to with the blog and so on. And then we have our personal pages, right? Like my page is on there with all of my stuff on it. You can go to my blog, for example, and see stuff that I'm posting or whatever. So it's pretty handy. And then Anna's got kind of an old school blog. She still has one at Tumblr. With her old artwork on it and stuff like that. So anyway, it's pretty easy to use if you ever want to browse around there and just find Molly Rocket stuff. It should work really well on mobile too, so if you're just killing time or something like that. Anyway, so let's go ahead and get started. what we need to do now is actually, we should, before we integrate the PNG reader into Handmade, we try to figure out whether we can even load the files that we need to load. So first thing you're going to want to do if you're following along at home is there's a new art pack up on the download link that you got to get. So this is the new art pack. It's Handmade Hero Art Pack 1.zip, and it's a bunch of test art in the right format that is basically examples of all the different sort of stuff that we want to be able to load. So like NPCs, playable characters, like block tiles, coverage stuff, a title screen, and so on. So like all the stuff that we might want to load is in there. So the first thing we're going to have to do, obviously, is we're going to have to unpack that stuff into some place in the Handmade Hero directory that we want to load things from. Now we've got a data directory here, and the data directory has a bunch of stuff in it. That's what the game loads. What I want to do is make a differentiation between those two things. So I want to create a separation, directory separation, just to make it clearer between data that the game loads and data that the artist works with. And what's in this art pack is for the first time, because we're trying to get a pipeline that runs at runtime in the game running now, where it'll suck in art as it comes in at runtime, is I want to make a different sort of directory for the source files. So I'm going to make an art directory here for the first time, and I'm going to unzip this art pack in there to differentiate it from data, because data is still, I think we're still going to want to have these HHA files, which are like what we consider to be the running package that we would ship with the game. So this art is really not what we will be loading for the actual game necessarily. It's just what the artist would dump art into and expect the game to load it, right? So it's different. So anyway, if you look at how these are structured, there's a couple different things in there. There's like, for example, these template files. I'm gonna use the Photos app to view this here. Actually, you know what? Do I like Photos? Well, it's fine. So if you take a look at the template file, you can see that it's got like a little bit of information on it, like floor state 1, floor state 2, worn, and then the direction the thing's facing. There's one for character files as well. Where is that? Character templates. Can I just have this listed as... There we go. That's what I wanted. Okay. So if I open up the character template one, which you can see here, I don't know why it insists on like, do you notice how the lines go away? It's like its blending thing like gets rid of the lines or something. I'm not sure what's going on there. How do I... Yeah, you can see there's lines there and they like disappear. That's some pretty questionable Zoom code there, Microsoft. Anyway, so what you can see here is there's just a template file. It's got a grid in it. Maybe if I load this into a program that was written by somebody who knew what they were doing, we'd be able to see those. Let's see here. Let me go and load that. Keep that. Yeah, so you can see the grid here because this was written by someone who's ever heard of graphics and knows how they work. So you can see here there's like a grid and it's got columns and rows. Default dodge left, dodge right, move, hit, attack, 1, attack 2, default surprise, anger. This is how the artist laid out the different things, and they just packed them into a file so that they're easier to load all. And you can see here the body is at the top, the head's at the bottom, and there's directional arrows like right, up, left, and down. And these are just to remind us, and we will use this as well to remind us how we're doing there. So also before I go in, I'm going to go ahead and switch this back because whoever wrote that program is really should probably be fired. I'm going to go ahead and switch it to a program that actually can resize an image without losing all of the information in it. Because I think there is we need a viewer like the old viewer that actually works. Let me see here. Because there usually is one that there's just a photo viewer thing that actually works, right? Or at least there was one. Maybe if I click on an other type of image or something. Open with. So those are set to GNU right now. Yeah, I just don't know how to get back to having it open in like that default one. You know the one that I'm talking about that just comes with it? Where is that one? Because that one actually sort of worked. What XE is the Windows 7 default photo viewer? Hello, 7 forums. Windows Viewer is run by DLHost. Oh, okay. So for the command line, you would use this. Okay, so it looks like you can maybe set default programs. Maybe that will work. It looks like they got rid of it though, like from those settings. So we something with Microsoft. It's like they can't even draw a picture. That's where we're at. They can't not even load an image. They were like, yeah, sorry man, I got nothing. I have no idea how to draw a picture to a screen. Let's see here, default programs. Set your default programs. Nah, it's gonna launch that thing again. Yeah. So let's see. I don't know. Maybe you can't get it back? There must be some way. Thank you for like inundating me with ads. But that didn't work. Copy the code of this post influence into Notepad and save it as a reg file. Double click your new reg file. All right, we can do that. So here's the photo viewer stuff. Yeah, we could try this. This looks legit. It's only modifying those classes. Let's give it a shot. Can't believe I have to do this to view an image. This is a new low even for Microsoft, who honestly is like the expert of plumbing the lows lately. All right, I don't know if we would have to launch Explorer for that. Because it looks like I still don't see it. Oh, there it is. Yes. Yes. All right. Thank you, CNET. Now, there we go. All right. So I don't think they are loading the transparency right on these pings. So there's that. But at least, let's see. Yeah, so at least it can show the grid, right? So the person who wrote this wasn't like a complete tool. They had some idea what they were doing. Not a whole lot, but at least they can sort of do something, right? So now we can at least see the file in some semblance of what it actually contains. All right, so what we want to do here is we want to start taking these files and we want to start bringing them into the game, and we want the game to be able to process them. So you can see we've got some NPCs here, right, that we can stick into the orphanage, just a bunch of random orphans. And then we also have the Handmade hero one, who's the actual main character, which has some test lean animations as well. Well, not animations, but extra frames, if that makes sense. And also some expression test stuff. So we can play around with that and see what we actually want. We also have some cats, which is important. These are some tile sets, right, so that we can actually have, so that we can wrap some things onto our cubes that maybe look like wood or like stone or like walls, right? So we can play around with those as well. And then we have some base green ones. We also have a little title logo we can put up there, and some example like ground cover stuff. And basically the goal here is just to take some of these things, and some attachments for characters like hats, hands, things like that. Also ground cover and stuff like that. So basically we have stuff we can play with, and our goal here is just to put these into the game and get them working so that we can then kick it back to Anna so that she can actually draw stuff in the context of the game and see what looks good, you know? Because at the moment, there's really no way to do that, right? She can't really get any feedback about how the thing should be drawn or what they should do, right? Okay. So that's really all we need here. So we've got all this stuff. So you can see our path is completely laid out before us here. I should probably put this photo viewer reg thing into the MISC directory potentially, because honestly, like, we may need that again. If Windows decides to give us another crappy photo viewer that doesn't work. So that's all you should need to do with the art pack. Once you've got that all unpacked in there, you can get rid of the zip file. We won't need that anymore. We just need it to be in the directory where we can get it. And so then we can start the process of trying to figure out how that's going to go in there. Now, like I was saying, before I go any further, because I don't really want to get into the... I don't want to go too far down the process of getting Handmade Hero ready to read PNG files and integrate them into its dataset until I actually know whether we can read these PNG files in the first place. Because we've only tested the PNG reader very lightly, and so what I want to know first is, can we read these files? These were output by Photoshop. That's who we want to be able to read the files from. And so I want to start testing these files to see whether Photoshop puts anything into its PNGs that's different from the PNGs we were testing from GIMP, because that way I can tell whether there's any kind of stuff that we forgot to implement or implemented wrong, that we just, like cases we just didn't hit because we didn't happen to ever see them. Like they don't occur when you're using GIMP. GIMP's compressor is different than Photoshop's compressor probably, right? And so we want to be able to just get some perspective on whether or not we're going to see something different here. So if I go to the Handmade art directory here, like so, I can just pick something. Maybe we'll load the character for the hero, so just character hero.png. And then we'll just write that into the temp directory as a bitmap. And we'll just run the program and see, does it even work? Does it crash? Whatever. So this is perfect, right? You can see we found something already. This should not have happened. So this is what I want to debug first. And I want to debug it here because we've got a nice, simple program set up, which is designed to just do one PNG read, so we can find anything that is not what we would expect, right? So when we were parsing the PNG here, we went into some kind of a into a consume bits run where we were trying to copy a giant. In fact, this is a block copy of this is a copy of an entire large chunk of data. Oh, you know what? This may just be a very simple problem, actually, now that I think about it. We don't really handle huge block copies that cross multiple IDAT chunks, do we? So that could be a problem. Of course, looking at this, this is only one IDAT chunk, so there must be a different bug in here, right? I think. So anyway, we're gonna have to take a look at this a little bit more carefully because there's only one IDAT chunk, so that's not the problem. But I do think, if I'm not mistaken, I feel like consume size in this case wouldn't work if it was split over more than one IDAT chunk. You know what I'm saying? So I might slap a to-do in there just because I feel like for completeness sake, that's not the problem here, but I had not thought about that before. This really needs to be a loop that consumes as much as it can from the current IDAT chunk and then moves. So just to leave that in there, because I'm pretty sure it wouldn't work, right? You'd call consume size, and consume size would say, I want 50 bytes, but there's only 30 bytes left in that IDAT chunk. That'll just fail, right? There's nothing it can do to fix that. And so what we would need to do is make it so that once you get the length, there's like a thing where you're like, hey, consume as much as I can up to this amount, and then if I can't consume it all, I'll just loop inside there doing as much as I can. So this would have to have a for loop in it, basically, right? It would have to have a thing around the outside. But that's not our problem currently, because this is a single IDAT chunk at the moment. So we shouldn't actually have that issue here. So we should be able to debug this separately. Oops. What's going on? There we go. We should be able to debug this separately, because since this is inside a single IDAT chunk, we shouldn't have that problem. So we start off here doing some bit consumption, right? The standard kind that we normally do. Let's see what we get. We decompress this stuff, blah, blah, blah. Just copying some literals here. Let's see what happens when we exit out. I don't know why I can't set a breakpoint there. Probably because Visual Studio's debugger keeps getting worse. Eventually, what's going to happen is a really bad debugger for Windows is going to be better than Visual Studio because it's losing all of its features. It's nuts. All right, anyway, so I just want to take a quick look. I'm going to try to figure out how to set a breakpoint that will actually work there. So this is probably my best bet. Set a breakpoint on the case that actually breaks out. Okay. So it goes through many regular blocks, and those all seem to parse okay, because you notice we're never hitting like a lit-len count problem or anything like that. So it looks like our Huffman table, at least for the most part, works correctly many times for what it's worth, right? So we're at least not completely messed up. What I don't know is, let me see where we are in the image right now. So we know that the length of this, so if we go look, for example, at how big the image is, right? So here's the file we're actually reading. So if I look at the details here, you can see it's 8192 by 8192, right? So it's an 8K by 8K image. So each line of the image should be 8192 times 4 bytes per pixel, plus 1 byte for the filter. So if I want to know how many rows this is so far down, I should be able to divide this by 8192 times 4 plus 1, right? To give me which row we're actually on. So we're on row 4763, supposedly, and you can kind of see us jumping through the file here, jumping through the file, blah, 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 blah. And we're still jumping through the file. Okay, so is this just us handling some kind of a padding thing wrong? It looks like we decompressed basically the whole image. Let's take a look at the actual byte count difference here. So if I want to know how many bytes are in the image, right? Again, 8192 times 4 plus 1 is the size of one row. So 8192 of those is the total. What you can see here is we've gotten to almost the end thus far. Let's take a look at where we go from here. So we're gonna do one more. So we've that's the end. Like the image is done. It's over. So B final should have been set. So I mean, the only bug here, as far as I can tell, is that B final isn't set. What's going on? B final still isn't set, even after we've decoded. Did I do this calculation wrong or something? I mean, that looks like the whole, that's the whole image, right? I mean, we've decoded the entire, there's nothing left to decode. Why hasn't B final been set? Are you folks as confused about this as I am? All right, so here's what I'm going to do. I want to see what the image was, because we've decoded all the bytes. Did we get them all wrong? Are we just like way off here or something? I'm going to set it to just run straight to here. Just straight up, right? So I'm going to call PNG filter reconstruct to do, the back transform on it. And then we're going to write it out, because I just want to see what it looks like. So if I go load that up in GIMP, so that's in our temp directory. It's this guy right here. So I'm going to open that up. So here's what we loaded. The alpha channel does not appear to be there, which I don't think is our fault. I think that's this program's fault. I don't know if we have anything that can actually read the alpha channel out of a bitmap. My recollection is that GIMP screws that up. Now, of course, we may have set the channel information wrong. For that, I'm not sure. I don't know if we need to set other information for that. But ignoring all that, like, we read the image. I mean, there's no chance we were not garbage. So we read the whole image. So now my question is, what's going on with this stream? Is there something in the spec that says that you don't need to put in a B final chunk if you know how big the image is? You can just stop? You know what I'm saying? Does that make any sense to anyone? Like, is there something that says, hey, look, I don't need to set a B final. I don't need to set B final if you know how big the thing is. I'm just gonna end without ever setting that. Because it seems like what's going on. I mean, that really seems like what's going on there. I mean, unless, I guess, let me check one more thing. Is it possible that the width and height are not what I think they are or something? Like, is it not what was specified in the file, you know? Also, we can get rid of this now, can't we? No, I mean, that's what it is. So what's going on here? I guess I can go back and look at the spec. Did we miss something, or are these PNG files just garbage PNG files? Like, did Photoshop just write them wrong? I mean, because one or the other has to be true, because it doesn't look like we're getting anything wrong. It looks like we got everything right. So either we're just wrong about the spec, maybe? I guess. So yeah, all right, let's see here. So let's look at page 5. Yeah, I don't see anything in the deflate spec which would suggest that. So how about the zip spec? Not particularly illuminating. Check PNG. Let's see. So we've read this a bunch of times before. I mean, it says a marker bit in the final block identifies it as the last block. So, I mean, either these are broken or somehow we read just that bit wrong. Like just that one. I mean, maybe it's possible that just that one bit happened at just the wrong time in the stream, that some in a way that no other bit would ever be wrong. Seems far-fetched, but, you know. PNG also uses compression in method 0 and I-Z-. We don't care about those. We don't read those. So I don't see it. So there's some kind of like appendix, gamma handling, color handling, alpha channel creation, depth scaling, palettes. The encoder may divide the compressed data stream into IDAT chunks however it wishes. Multiple IDAT chunks are allowed so that encoders may work in a fixed amount of memory. Typically, the chunk size will correspond to the encoder's buffer size. A PNG data stream in which each IDAT chunk contains only 1 data byte is valid, though remarkably wasteful of space. Zero-length IDAT chunks are also valid, though even more wasteful. Text chunk processing, use of private chunks. Errors in a PNG data stream will fall into 2 classes: transmission errors and syntax errors. Transmission errors, blah, blah, blah. Detect errors are impossible. The decoder can have confidence in the data stream's integrity. If the next data bytes are added, okay, blah, blah, blah. There's really nothing. Critical or ancillary is not really relevant to us. I don't see anything here that suggests that we wouldn't expect the final bit to be set, though. Non-square pixels can be represented, but viewers are not required to account for them. Sorry, non-square pixels, rather. That's fine. Blah, blah, blah. It is important to say that IDAT chunk values have no semantic significance can occur at any point in the data stream. There's no required correlation. But in the image data, yep. The complete image data is represented by a single zlib data stream that is stored. Yep, the decoder says more than. This is incorrect. Some encoder may emit data streams in which some of these structures are indeed related, but decoders cannot rely on this. That's fine. Interlacing and progressive display. I don't care about that. Blah, 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 blah. We may need to look at that alpha channel processing stuff to get the alpha right eventually as well, if just for gamma stuff or whatever, because there might be information there we need. But so I guess what I would say is I'm kind of tempted to just put in a thing that checks to see if we're at the end, and if we are, we consider that be final. You know what I'm saying? Yeah, I don't know. I guess people don't generally refer to it as B final. So I don't know. I don't know what to make of it. I mean, I did my due diligence reading there. Here's what I'm going to do first, because I really don't know how to proceed from something like this, since I don't have much else to go on. What I'm going to do is I'm going to look here and say that when we come back up to the top, I'm going to say this. And what I want to do here is just see, am I right that we actually, if we terminate at that point, does the rest of the, I mean, does it just work, right? Because I don't know how else to interpret it. It doesn't seem like we could have a bug where it'd be really hard to have, I mean, maybe there's a way to have it, but it'd be really hard to have a bug where we decode the entire thing correctly, and the only thing we get wrong is just the B final bit. Like, I'm not sure how we would do that. You know, maybe it's possible, but it seems pretty tough. So I just want to see what's going on. How come that didn't, what happened there? How come that didn't show me where the break point was? Okay, so there isn't one. So if we just run, then we get the image back, and it's right. The B final bit isn't set, and I don't know what to make of it. Let's try a different one. Can we get any other kind of error to occur? I guess would be my next question. So let's suppose we took, like, I don't know, just some other random one. I mean, it's so weird, right? I mean, it looks like their encoder's just busted. I mean, that's what it looks like. I don't know what else to make of it. Again, it's possible we've got it wrong. It's possible we're doing something wrong. I mean, we've done very little testing on this PNG reader, so it's well within the realm of possibility that we just did something wrong. However, it's kind of a pretty tough. It's hard to think of how that would happen, right? Like, that's a pretty tough thing to get wrong in a way that only does that, because those bits aren't even encoded, right? Those bits are raw. We're not putting them through a Huffman table. They're not getting translated by any kind of algorithm. We're not looking them up in one of those extra bits tables. We are literally just looking at a bit in the file and saying, is it 0 or 1? And it seems like it's 0. And it should have been 1. And everything else is correct. So it looks like if I zoom in on the last row of the image, I mean, I don't see any garbage there either. So not only, this looks exactly right. This is what Photoshop does, by the way, in the color channel. The alpha is probably right, but we can't see it, if that makes sense. It would be nice if we could, and I guess we will be able to see it soon. We'd have to do a TIFF reader. I remember like almost nobody reads alpha out of BMPs correctly. That's my recollection anyway. So in order to see if the alpha channel is right, we would have had to have done something else there, if that makes sense. What we could do, there are some things we could do if we wanted to, in terms of making it a little bit easier for us to see that. We could do something like blend, instead of just swapping the R&B rhythm and blues, we could actually blend to a pink color or something that would make it clear. So even though the alpha channel is getting ignored, we would still have some way of seeing what the actual alpha channel was. But I'm not so concerned about that at the moment. So anyway, just looking at the, I don't know why this is still here. I don't know. I think I'm just going to push forward in it. I'm going to put a to-do there. I think it'd be interesting for someone to research, find out whether we screwed something up or whether the Photoshop PNG writer is just wrong and it's busted. So we'll see. I don't think it's worth going down that road at the moment because, like I said, this PNG reader really only exists for one purpose, and that is to get the art into the game. As long as the art is loading properly, we don't care if we hacked around something. So I'm fine with that. I would like to know the answer because while it would not surprise me, it would not even raise the smallest amount of surprise within me to learn that Photoshop could not write a PNG file correctly, because that is so typical. That would not surprise me at all. I just don't know that that's true, because since we have very little experience with PNG loading, we only just wrote this thing in a couple hours, and it's our first time ever looking at the spec, etc., etc. I'm not in a position to say that they did something wrong or did something right. So I would be interested to know a little bit more about that. Maybe ask some people who've done PNG readers before. Have they noticed that discrepancy? We could look to see if there's any docs in the STB libraries about that. If, you know, for all I know, you might have mentioned that. Like Sean might have been like, hey, Photoshop files don't do this right. Or we could look to see like, what's this? These are BMPs. So this is the image transform stuff. Yeah, you can see. Here you go. So let's see here. Here's parsing a single Huffman block. Here's the Huffman code generator. Here's the uncompressed block. So type 3. So it looks like, at least here, it doesn't look like there's any kind of special out. There's a bunch of return 0 kind of stuff, but yeah, so I don't know. I'd be interested to try running the code and see if it actually, like, run it against STB image or something and see whether or not it properly gets the final, right? I mean, or something, just to see if we're totally out to lunch on this one or not. Because I don't see anything in here that stops it that way, right? It looks like it requires final to have been properly set. Just like we do. And, you know, I don't know. I mean, what we could do here too, right, is we could just run this right now. Let's just run STB image on it, see what happens. That seems like worthwhile. I don't know. I kind of want to do it because I'm just curious. I don't understand how we're able to decode everything else properly. And so it'd be nice to see what goes on in another compressor so we could see how we could even have this bug. So let's put STB image in a temp directory here. And then all I'm going to do is just go into the temp directory and make like a simple file that uses it, right? So this is STB PNG test .cpp pound include STB image.h main. And this will just, we'll use the exact same thing here. We'll just do it with STB image in this program so that we can see, so we can step through it, right? We just need something to build STB image so that we can step through it. And we don't need to write, we don't even need to write the output because we don't care whether STB gets the output right or not. We only care whether we only care to see whether or not it gets final back as a 1. That's all we want to see. So we should be able to just say from here, in fact, it doesn't need an out file name. You can just do that. This, of course, is more correctly written that way. So all we need to do here is replace that part of the code with something that loads it from STB. Let's grab that. There should be an easy example in here that we can use. Let's see. Ping support, blah, blah, blah. Where's some example code, please? I don't know how to use this. Basic usage. All right, so there you go. So that's all we're trying to do here. Oops. We're just trying to load from in file name, and we just want to be able to step through that, right? So now if I pop back over to the shell and I go into the temp directory, I should be able to just build this, right? And oops, what's 14? Gotta put semicolon. Should be able to just build this, and then if I ask it to load the same file, so that we were asking it to, which was the character hero bitmap, we should be able to now go into the debugger and watch that loop run to see what they got. Does it get the same thing we get, or does it get different? Because it'd be interesting to find that out. So the art in question here is the character hero. Oops, it's not test. It's art. Character hero.png. So if I just run it like so, we should now be able to jump in there and see what it got. And that's really all I want to know. So I'm going to go ahead and do an msdev on that. Oops. No. I love how you can't tab complete in the middle of one of these. Like it deletes the rest of the line. So good. Whoa! Oh, oh, that was funny. It actually loaded that PNG. That's not what I meant, but okay, that's fine. Good job. That's good. It did it. All right. So there's the argument. And so what I need to do in order to debug this, I'm going to have to actually pass a debug string to it there. So what is that? That's like /z7 or something. Is that what we want? Yeah. So we should be able to step through this now. You know what I could also do? I don't think it will by default, but we can also just make sure that optimizations are disabled because we don't want to have to deal with that either. So if I step through here, I should be able to step through the STB image loading code, just see if Sean gets the same thing we get, and if not, maybe we can get a hint as to what it is we did. Because it's weird that I just don't know how we could have gotten everything else right and that wrong. It's kind of bizarre. So we should be able to do this ping test here. It should return true, and we should be able to do a ping load. So here's the ping load. We can set a breakpoint now somewhere that's actually more relevant to the ping. Should be up here somewhere. Create ping image is not really what we're looking for. We just want that one loop that I was just on. I could search for it, but instead I'm just kind of scrolling up like a mindless automaton. So we've got a bunch of zlib stuff here. This was where it was, right? It was right up in here somewhere. So here's the Huffman codes. So it should have been right down below here. Did I just scroll just right by it? See out. decode buffer, decode not chunk header, check PNG, draw. There's that part, so it should have been like right here. I must have scrolled right by it. Yes, I did. Or maybe not. Where is it? I had it up just a minute ago, right? It's STBI parse zlib. It's on line 4140. How did I miss it? Just blind, I guess. All right, so this is what we actually want to see. So let's jump in here. Parses the zlib header, and we start running. So I don't really know. Like I said, I don't use this library. I don't really know much about it. But presumably, if we take a look at the data structures here, we should be able to see, you know, like Z out, I assume, is like where the pixels go or something. So I'm assuming that like the start and end tell me something about that. So let me see. If I do Z out end minus Z out start, oops. You know, is that, yeah, that's the size of the image. So we know where we are in the image by looking presumably at the Z out value minus the Z out start value. And so if I want to, I can kind of loop through this, decompressing the image as we go, just like we did in our routine. And we can just kind of go up till we get within striking distance and then step through to see what happens on the Z final for that final chunk. And that should tell us, you know, what's going on. Right, so here we go, decompressing the image exactly like we decompressed it in our code. Nothing is probably happening atypical right now, I would assume. Of course, I don't know. Off we go. Not particularly exciting. Getting closer now. Okay. So now let's take a look and see if final is ever set, because that's what we're interested in. And so at some point here, we should see that flip to a 1. So this is the last block. Final is not set to a 1. At least I think it's the last block. So let's step through this here. Now we're at the end. Final is not set. What is type set to? 0, just like ours. We go into STBI parse uncompressed block, which is exactly what our decoder did. So Sean's code is doing exactly what our code did. He's attempting to decompress the header of the block, I think. Not sure. Getting some bits there. And let's take it into disassembly so we can see what he gets out of this if nlen. Took the jump. So he matched these two. Oh, interesting. So he got a length of 0. But we didn't, did we? So that would make more sense. If are we reading the length wrong? Is that's what's happening there? Because theoretically you could put a block in here that has a length of 0, right? Like this is just this doesn't do anything. This is a weird decoder. So, assuming again that it's right, it's just got a bunch of 0 length stuff at the end of it. So do we have that part of our code wrong? You know, that's are we reading this value incorrectly? Like maybe is our flush byte function incorrect? You know. Do we do something where we don't deal with the end of the stream properly? You know, I'm not sure. But we can see a very obvious difference between what we read there. And so I'm just curious to know what's going on with that. Let's take a look. Because we should be able to do it. If the SDB image library does it, then you know they're doing basically the same thing we're doing. So the question is, what did we do wrong here? Got to take this out. What I might also do here is I'm going to assert this because we never want that to advance past the end. So I'm going to assert that if it's at the end, it's okay because like we now know there's chunks that happen after the last chunk that just are length 0. So let's see. So okay, we got to go back to this one. Let's give it a whirl. Why can I not, why does it not know the file? Doesn't make a lot of sense. Why can't it, am I missing something? How is it different from the one that was built? All right. What is it this time, Microsoft? What did you do? So let's delete that, build. So now we know there's only one of those and we just built it with our current source code. Unbelievable. All right. So anyway, now we can actually get in here. And so here we are on flush byte. And let's just see if there's something that we're doing wrong in here that we can fix. So here's our buffer at the time. There's 12 bits supposedly still in the buffer. So maybe that's what it is. Our flush byte call, here's what it probably is. Our flush byte call is flushing potentially more than a byte. That's what it is. So I think that's what the bug is, right? Like our flush byte call, in this case, should only flush 8 bits total. And these should be things that still do a consume bits, and they should consume 16 bits, right? To make sure that we still work on the even boundaries. That seems like the right thing. Because flush byte right now can flush more than that. What it should do is say, flush up to the next 8-bit boundary. So if it's like 12 bits are in the buffer, you want to flush 4 bits, right? You want to flush mod 8, the bits, right? So I think what we want to do here is flush byte should really do a thing where it says like flush count equals buff bit count mod 8. So like what's the remainder? And then I want to do a consume bits on buff of whatever that flush count is. I think that's actually the more correct thing. Yeah. Okay, so I think that may have been the problem. It's just where the byte boundary was. So let's see so now when we read it, we get the right answer. We consume a 0 size, which is no problem. We come through here and I guess we have a whole Huffman table that doesn't do anything. It's just a 255. Okay, you know, who knows why Photoshop did that. All right, so we have fixed that bug. That's awesome. Thank you to Sean for the reference code. So yeah, that was a good bug to fix. While we're in here, should we do something about this? I'm not sure what we want to do about that. Basically, what that wants to do is say, hey, look, I might only be able to consume as much left as there is, right? So, you know, we could bound it on content size. So like it would look something like this. If we look at consume, oops. Yeah, so you can see here, like if we consumed exactly that, we could just make a function here, right? And this function just does the operation that is the fill. You know what, I guess now I think about it, I suppose we don't even really have to do that. No, we do. Oops. I think we do want that. So what we could do is say, all right, look, make sure the buffer is filled at the top. So refill if necessary. So make sure the buffer is filled at the top, and then say, look, we're going to have like a concept called useLen, and we're going to try to read len, but if we can't, then we'll just read as much as we can. Then at the end, we'll say this, right? So what we'll do is say, all right, if the use length is greater than the comp date, whatever the component, whatever the compressed data is, although in this case it's not compressed because this is the B type 0 block, but if the content size is not enough to fulfill the entire read, we'll just read it as much as we can. So we'll read up to the end, copy that out, and then we'll refill it again at the top of the loop, right? I think that should be sufficient there. Okay. So I think that should do it. And now we don't have that to do there. We can get rid of that. Because now we are actually looping, and we'll try to grab as much as we can. So that can straddle the IDAT block boundaries just fine. Yeah. So I think that's pretty good. While we're in here, since we're going to start doing this stuff now, the reverse table thing we don't use anymore. So I believe this table can go, right? That's not in there anymore. So I think what we should be able to do now is start moving this into our mainline code. And so tomorrow we can start actually getting these images in. Because it looks like everything's fine. It looks like we're reading them properly. We did have a weird bug there where we don't handle 0 blocks. But now we do. So I think we're good, and we should be able to proceed. So looking at this stuff, what I want to do is I want to now split this out, this code out into sections where I can, I want to basically have, insofar as I can, the PNG reader code is just in a thing that can be included in the game or still in a little test app like this, because although I think we're pretty good now, you know, we've got a fair number of test cases, we've debugged it, there's still probably some other bugs lurking in there, maybe, right? Found one today, maybe we'll counter another one tomorrow, we don't know. So I want to make sure that we can still pretty easily compile the PNG reader outside the game as well as inside the game. So I want to pull out the test app part, and I want that part to be still compiling the same code as the game. So the first thing I'm going to do here is I'm going to split that code up, right, into 2 parts. So I want, like, you know how in here we have like the like simple coprocessor, preprocessor, test asset built, right? I'm going to do a test PNG .cpp file. And what I'm going to do is I'm going to start to grab stuff out of here and plunk it down in here as necessary, right? And I'm going to leave just the very straightforward part of the code that does the actual decompression of the PNG. That's the only part that I'm going to leave in there, right? So just the decoder is all that goes in there, right? So all of this stuff is stuff that's going to have to get done in the actual game. So we're going to start to modify this code. But let's see here. What else we got? Yeah, all that stuff. Blah, 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 blah. Blah, 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 blah. Okay. So all of this stuff is stuff that we'll want to still have happen. And we're going to have to sort of make accommodations for all the things in there that maybe won't work, or that need, like we can't printf anything to standard out. So we can't report errors in here or anything like that. So we're going to have to figure out how to do something that's fine. That's not going to be a problem. So that'll all work fine. We just need now to go towards like merging those two paths, right? Okay, so we've got handmade PNG.h as well. Again, that's got some things that we probably don't want to put in there either. So we'll see how that has to go. I think all of this stuff does want to be in there. The only question is image U32. I don't know if we have something similar to that currently in the asset system. Something like a loaded bitmap that's got that same. We could just reuse the struct if we've got something similar to that. I'm not sure. So I'm going to take a look here and see if we've got something similar there. So we've got a loaded bitmap in there, but that's not what I was looking for. We want like that one. So that's not really what we want either. Yeah. So I guess we just didn't have one of these. I guess. It just didn't happen. So I don't know. I don't know what to make of that. So we will need something like that, and we can promote that maybe up to a more aggressive type at some point. And we'll see how that goes. All right, so anyway, going back to where we were. So all of this stuff is in the header file. It can exist in both places. It doesn't use anything that's specific to that either way. So the first thing we're going to have to address here is the error reporting. Error reporting in this case is not going to be able to go to, it can't go directly to a stream out. It's got to go somewhere else. And so what I'd like to do is start to figure out how that's going to look, right? So what I want to do here is talk about this image U32 thing that we had here, perhaps. And I want to think a little bit about how I want to do errors. So what I would like to do, ideally, I think, is I'd like to have it so that the errors just get buffered up. And we can, maybe have some way that those errors get recorded for later display, right? So that there's some kind of an understanding of what those streams are. So I'd like the debug, I'd like to basically have those, and they're not really debug per se. They're things that actually should run in the actual game in a sense. Because if you were modding the game after the fact or something like that, even, these are pieces of information that you would want to have. Like, oh, you tried to load a ping and the ping was corrupted, or the reader couldn't read it for some reason that it's palletized and we don't support that. So it's kind of like real error reporting. Does that make sense? So we kind of want to be able to support that sort of thing. So what I want to do is maybe have a thing here where I just have something called a text stream. I don't know. I'm just thinking out loud. And I just want to make a thing that daisy chains these together. So I have a text stream. I have a text stream entry. So there's kind of like a W-link list in here. And, maybe in here I've got, so I can just kind of of daisy chain these together. To some degree, I guess I don't care that it's a text stream. Maybe I just call this a stream because I don't care what I stream out into it. You know, it could be text, could be anything else. I don't care. So I could just say, look, it's just a stream of stuff. Right? So it's just something that I can buffer up information into, and I can dump things into the stream all day long. If that's what makes me happy, I can do it. And so off I go, right? So then when I introduced something like the streaming, the input buffer, right? It can have associated with it some kind of a, an error output, like where the error should go when an error happens on that particular stream. And that seems pretty straightforward. Now, what you'll notice is these are kind of symmetric, right? So what we could do is just make one of these that functions for both input and output, and it would work, right? So what you can kind of see when I started to sketch this out is this and this actually look the same. So what I could do is just say, look, this is now what this is. These are basically the same. I can make the content size be 64-bit if I want to. I'm not sure if I want to yet or not. That's the only thing that I would have to think about there. But otherwise, these things are the same. And so I can just kind of implement these using the same structure. So that tells me that I just have a thing that I want here, right? I want a handmade stream file. I want to have this thing in it. I'm probably going to want to rename it to just stream. I don't think it needs to be called streaming. Like we don't need to make a gerund out of it for no reason. So here we go, right? We've got the two. And I can just put all of those stream informations in there, right? So all of this stuff, consume endian swapping is kind of just generic. That can be put inside some other file. But yeah, all of this other stuff here, like peek bits, discard bits, consume bits, flush byte, reverse bits, all of that stuff can just go in here. And I think that's all we need, right? Yeah. Yeah. So what I should be able to do now is I should be able to rename these. Oh, it's a strom. It's a strom. So what I should be able to do here, like I said, is this streaming buffer should allow me to like stick stuff into it and pull stuff out of it now, right? And I'm gonna just rename it from streaming to stream because yeah, no point in really doing that. Inside Handmade PNG now, I want to include that. Inside not Handmade PNG but test PNG, and also inside the build file, I don't want to build Handmade PNG by itself anymore. It's actually test PNG. That's what I'm actually building, and I'll have to change the program that we're launching accordingly. So anyway, inside here, we've got to change the name of this as well. But once we do that, we should be pretty good to go. All right. So if I then go back and look here, I've got to include it like so. And I've got to include the Handmade PNG code as well. Yeah. Oops. Okay. So also in here, I will need the actual code. So I'll need handmade png.cpp, oops, and handmade stream.cpp. All right. Okay. So next thing we've got to do here is Handmade PNG is no longer a thing. Right, it's test PNG now. And so test png.exe is the actual exe we need. And in here I can set up its arguments to do the stuff that we wanted to do, just like we were doing it before. So we should still be able to run it, and it should still work, like I said, but we haven't really made any modification to it yet. We've just begun to split things up. So the first thing I'd like to do is maybe not allow access to any of these things inside the code that shouldn't have access to them. So I think we want to do something more like that. And that way, when we come through and do the compiler will now point out to us all of the places in our code where we are using things like an fprintf that we should no longer be using, because this code wants to be shared between the external reader and the internal game code, and fprintf is not going to cut it for that because we don't even have an fprintf in our game code. So now that we've done that split and we've talked a little bit about how that stream stuff's going to work, so what I want to do here is say, all right, if we've got an output stream, so maybe we change stream buffer because that's not very necessary anymore. We just call that to just stream, like so. There we go. Anybody else still doing that? Stream buffer. There we go. All right. So now what we need to do is make a version of this fprintf, right, that actually is going to be targeting a stream buffer instead of a C stream. So inside our stream function here, you can imagine us, taking a look at how we would get this in there. We need some kind of a function that writes to one of these buffers. So, we could do something like, okay, we've got a stream target here. We have the format string that's this thing, whatever this thing is, and then we've got a bunch of extra parameters that get stuffed in there as we go, right? Now the question is, do we want to make this potentially a macro? I think we might. We don't have an outf anywhere else, do we? Oops. So I think we might want to make this a macro, and the reason that I say that is because if we make this a macro, like so, then what we could do in this circumstance is actually provide additional information to the outf function that we wouldn't have had otherwise. So for example, we can provide file and line number information here, which would allow the streaming information to have additional debug info associated with it, for example, which might also be handy, again, just looking forwards. So something like that may be interesting and relatively easy for us to do, pretty cheap. So if I change all of these and say, okay, from now on, every fprintf is actually an outf, right? Now all of those functions will be correct. However, They have kind of arbitrary stuff like standard out or whatever in them. Why? That's a weird error. Did I mess up that macro? I don't think that should be the error that we're getting here. I totally messed that up. Don't ask me what that was supposed to be. That's where I wanted to put that. Let's try that again. Yeah. So now we're fine. The only problem that we have here is that when we're doing our outf, that first part there, like standard error or whatever, excuse me, that isn't actually a real target, right? We need to provide an actual stream of some kind that we can use, and we're going to want to make that a little bit more we're going to want to make there be some way that it can automatically tell when it does consumption on a stream where the error should go. So what I want to do is have every stream can have another stream that it just points to, and it can do so or not. It could be a 0, and I'll be fine with that. And if it's a 0, the errors just won't get reported anywhere. But if it's non-zero, then the errors on that stream will get reported to the error stream, right? So they just get dumped in there. And maybe on the stream chunk thing here, we'll also say that this can have a file and line number attached to it as well, right? So basically we can keep track of where any given stream chunk came from, and then we also have information about, for any given stream, where the errors go on that stream. So what I can do here is say, all right, we know where the errors would go here. They go to the errors on an underflow, right? Let's keep looking. So in here, for example, when we load in the this PNG, what we could do is say, well, you know, these aren't none of these are errors. These are informational. So what we could do is say, look, when you parse the PNG, you can also give me a stream that's just like an info stream. So just, you know, a place where you want me to send any informational output that I'm going to have. Oops. Right, so all of these are just informational. They have nothing to do with errors. So then when we have our errors, again, on this, we know exactly what we're talking about here. It's going to be the errors stream of that compressed data. For the filter reconstruction, if it's going to have an error in there, that needs to, again, have an error stream. We don't have the buffer here, so we're going to have to pass it. So then when we come through here, again, that's the comp data errors, I believe. And then in the PNG filter reconstruct, oops, same thing. So then when we parse the PNG, we want to be able to provide both of those things. We want to be able to provide we want to be able to provide a stream for information as well as a stream for errors. And so that's what we're going to do here. So what I want to do is start up by creating two streams. And all I'm going to do here is say, look, I want you to make a new expandable memory stream. And maybe it's not even an expandable memory stream. I'm just going to call this like an on-demand memory stream. So like basically every time you need to put something in it, you know, allocate more space, right? Just, I don't know, you figure it out for now. So we'll get a little bit further down that road in a second. We should probably pass a memory arena here that the stream would use for growing its size, but you know, we'll cross that bridge when we come to it. So these now, again, can also be done this way, so we can kind of unify this stuff into one place so that we don't have multiple dependencies here, so we don't depend on the C library for things we don't really need to. So that would unify all of that. And then if we take a look up here, we kind of have some other things where we're like, okay, you know, read entire file, that has errors. We can pass a stream there for errors as well. And we want to do that because when we have this stream that comes through as a result, we want that stream to get the error stream that we're talking about here, right? So this will also be an outf that goes to whatever the error stream is for this result file, because that's where that should go. Same thing would happen up here where we do the write top-down image. We print out an error for an unable to write the output file. We might as well, again, just go whole hog and have the error stream be passed in there. Like so, and oops, go. So we need to implement that. But once we do all of that, then this stuff would just work. Okay. Parse PNG also needs to take the info stream, but I think that's it. So then we're down to just, okay, now we get these things, the info stream and the error stream. Those streams are things that now have all of that stuff baked into them. What I would like to do now is just have a way to recover that information. And of course, it's pretty straightforward for us to do that. What we can do is now just say, all right, let's do a for I loop through the chunks of the stream that we're talking about here. So let's do stream chunk equals info stream. Let's just do it this way. Let's say stream first, chunk equals chunk next. That loops over all the chunks in a stream. Then what I can do is say, all right, whatever the dest is, I'm gonna do an fprintf to that destination with whatever the contents of the stream actually was. I can actually do that as an fwrite in this case because we know the size ahead of time, so I can just say whatever the, I think it's actually like that, whatever the chunk contents are, I'm going to put them out to that destination file, and I'm just going to do that for all the chunks, right? Now what I would also like to do is in between those, I'm going to actually, just because I can, print out the file and line number information, because why not? So what I'll do here is say, okay, here's the file, here's the line, and then here's the stuff as it came. So the file name and the line number, these are optional. We don't have to print these out. I'm just deciding to. So that's all good. What I can do is then make this into a little function. This is going to be called something like dump stream to C runtime library. And what this will do is it'll take one of our streams and then take one of their streams and do the copy. So then when we get to the end, I can just say, all right, let's do a dump stream to CRT of the info stream and the error stream. This will go to standard out. This will go to standard error. And what I can also do here is actually just do an fprintf that says info, and then another one that says like errors or something like this. So those will be separated out and easy to see. I think that's all we really need for the boilerplate. So what we need to do now is just actually have some way of getting these things allocated. If I go to the stream functions here, I can define this as something that we will do, like so. Excuse me. And then our problem is that, these two functions are now getting used, but they don't exist anywhere. So if I come through here and actually make them exist somewhere, as you can see, we should compile. And moreover, we should actually run. And what'll happen now is we just don't get any output, right? And the reason we don't get any output because those streams don't dump anywhere. That's totally fine. We don't care. We can address that later. So I'll go to the Q&A now. And then tomorrow we'll start integrating that stuff in. So what is the focus now, this logging error system? Well, it's not really a system. It's just some place to put the errors on the PNG. I don't know that it's a focus. Right, I mean, at the risk of restating exactly what I just said about 20 minutes ago, so if a PNG fails to load, we need some way to see that it failed to load. But we need to see that it failed to load in the game. And moreover, we need it to be associated with the PNG that failed. So instead of these things going to the console, they need to go to a buffer that we can print in the game. Make sense? So everywhere we call fprintf, we just want to make it shunt over to somewhere else. It's not a system. It's really straightforward. I'm not sure how that's, I don't know yet. I don't know how that got confusing. But point being, you can't call fprintf if you're not a console app, right? So you need somewhere to put that error information. And furthermore, an artist is not going to want to look at a console. So what you want to do is when they put the PNG in and it doesn't load, you want to have a thing in there that's like, hey, this BMP named this that you just tried to load, here's the errors. And you want them split. The reason I split them into two different streams, info and error, is because the errors are the only ones the artist should probably be seeing. You can do that in a couple of different ways, but what is the focus now? This error logging system, we answered that. I haven't been following the PNG streams closely, but how satisfied are you with the code for the reader? It seems fine to me. I mean, I'm satisfied as long as it reads it, which it seems to be so far. So I'm pretty happy with it. It didn't take very long to write, and it reads the files. That's really all we cared about. We don't have any other requirements for it. If that makes sense. So in other words, we don't need this reader to be fast. We don't need it to do anything other than read just the bits of the image. So, as long as it does, we're done. And it seems like it does. So I'm happy with that. Could you explain the bug that was solved again? Sure. So the bug that we had was that the PNG specification specifically says that if you, not the PNG, that's slightly misstated. The deflate specification, which is the algorithm that PNG references for its compression. So it is effectively the spec for PNG, but it's not in the spec for PNG. It's a much earlier compressor that the PNG is just saying we're using it. The spec for deflate says that if you get a block that is uncompressed, so it does not go through the Huffman stuff, then first, before you read the sizes to copy uncompressed, you must flush any bits that you still had left over from the Huffman stuff, right? The problem was our Huffman bit buffer was 16 bits long, but the spec says only flush up to the byte boundary. I flushed the whole 16-bit boundary, which means that we flushed 8 bits more than we should have, because we had 4 bits left in the buffer plus 8 bits, because it was 12 bits total. I should have only flushed 4 bits and then started using the 8 bits that came next. Instead, I flushed all 12 bits. So the fix was just only flush up to the next byte boundary. Don't accidentally flush a whole extra byte if your bit buffer happens to have that in it. That's all. Is to do comment still in the code? I don't know. Which part are we talking about? Looks like that's the only one we've got. We've got plenty of to-dos elsewhere in the code, but that's the only one that's in that particular file. So... Any plans to switch to LLVM anytime in the series? No. Although when we compile the code on Mac or Linux, assuming we port to those platforms at some point, they are Clang based, so we would use LLVM on those platforms. It's the native compiler. And that's a good question, by the way, Asaf, about whether you can load BMPs with alpha inside Visual Studio. I have no idea. Doesn't look that way. Or we may be setting the bitmap values wrong, but it doesn't even think there is an alpha channel, right? So I don't know if we need to set something else. You know, maybe we need to set some other flag in the header to get it to understand. I seem to remember us having to do something like that originally. I don't know. I don't much care because we don't really need to know that. But, you know... For reference, if you care what the alpha channel is and you only have a bitmap writer, you can also, it's pretty easy, right, to add test code that will give you the information you want. So, you know, what you do is you just say, like, something like this. So what you can do is just say, like, oh yeah, okay, so, you know, something like this. So when you come in here, and this is, you know, because since this is not performance critical code, you can just have a flags that just says like, or, you know, pixel ops. That's like, hey, do you want to replicate the alpha out? And do you want to swap? Something like this. And then you just implement those, and you can write out the alpha channel and see what it actually is. So, you know, in this case, we would just say, okay, the alpha is just C shifted down by 24. And then you put that in every channel. Right, so this allows you to make something that'll do a bunch of pixel ops to the thing that, you know, whatever you want to do. And so then when you write it, you can write it twice, you know? So you basically say like, oh, yeah, you know, there's an RGB and an out A, and we check to see RGB bitmap to write, A bitmap file to write, or alpha. And then we just write both of these. Like so. So we just need to put then in the flags field which one of those we want to do. So like pixel op swap bar and pixel op ripple A or whatever. So that's really it. And then if we were to run this code, we should be able to then ask it for both of these things. So like there's an RGB version, and then there's a W temp character hero A, you know, an alpha version. And you know, I kind of slammed that code, so I'm not sure if it's right, but you get the idea, right? So here you can see. Let me delete this. I messed that up, sorry. There. So if I run that now, it should put the RGB out to one bitmap and the alpha out to another, right? So here's the alpha channel, right? And you can see it's nice, looks like what an artist probably made, right? And then you can see the RGB part here. And you know, you can have other stuff. You could have other ops as well, ones that you could multiply. You know, you could have the alpha like the alpha could multiply the image, so like put out a pre-multiplied alpha, right? If you wanted to. So there's a lot of things you could do, like if you want to see something like this. So isolate the channels. right? So that gets us out channel 0, channel 1, channel 2. We get out the alpha. Then what we can do is just like multiply each of these, right? By the alpha. Now the thing you have to remember is it's like 255 times 255 is not 255, right? This is not floating point. So you end up with an alpha value that's not actually correct there. So you need to shift it down by 8. This is a lossy multiply. So you actually 2d5 to 2d5 shifted down by 8 is going to leave you with 1 bit missing. So instead of 255, I can show you what I mean. So if I take 255 and I multiply it by 255, it's 65025, right? Dividing that by 256, I don't get 255, right? So I lose 1 bit out the bottom. Just so you know, if you actually want your 255 to equal 255, you have to do the math a different way. And we're not going to do that right now. We don't care about that at all in this code, but it's just so that you understand what we're talking about here. So if I then repack the results, now we've got a mul alpha, and I can put in here like that. So another thing we could do is for the RGB channel, right? If I wanted to, I could put in a mul channel op there so that, when we run this thing, it'll clear out the parts of the image that that didn't have positive alpha values or whatever. Oh, or not. What did I do wrong there? That was cool. Did I swap the channels? C0. Oh, no, I just didn't use the swap channel. I need to still do that. There we go. And of course it helps if I actually call it. So, what did I call? I don't remember what I called that. There we go. So now when I call it, it should clear out, the part of the image, the part of the RGB that doesn't have an alpha value will get cleared. And so you can kind of see that composited together if you care, right? So this is a pre-multiplied alpha image now. Just gives you ways of viewing them. So if you only have a 3-channel output and you need to see these, it's not the end of the world. It's still pretty simple to do. Will there be any blog posts on Molly Rocket for any of the projects anytime? I kind of missed those. Yes, actually, there will be. Maybe a month or two. Sinocrown, I am confused why you shift the multiply down by 8 bits. Wouldn't you want to mask with OXFF? No. So what you have to remember is that when you do a fixed point multiply, which is what this is, the basis gets multiplied in and must be corrected for. And that's really what's happening here. And since we've never really, well, maybe we have covered this, I'll just say it again. So what happens here is we're really trying to say that we have a number between 0 and 1, right? And ideally, this would be 0 to 1 where we include both ends of the interval. And in floating point, this just works. We have 0.0 and we have 1.0, and anywhere in between. These work exactly right to within floating point precision. So 1.0 times 1.0 equals 1.0, right? 1.0 times 0.5 equals 0.5. These are exactly what we want to have happen. Half of the 1.0 is 0.5, right? But what happens in, FP could also be fixed point. So let me just say in float, right? But in fixed point, something very different happens, right? Because when I say that I have 0 to 1 in fixed point, what I really have is 0 to 255 over 255, right? Make sense? So it's not this. It's this. So when I look at these values, if I look at exactly these three things, if I have 0.0, that's actually 0 over 255, right? If I have 1 times 1 equals 1, what I actually have is 255 over 255 times 255 over 255, right? That's what I actually have. And I want that to equal, this is what I want, that to equal 255 over 255, right? That's what I'm actually trying to do. The problem is, it's just happening in the CPU in an integer multiply. It doesn't know there was a secret over 255 in the mix. It just sees 255 times 255. And so if you get rid of all of these divisors, which is what will happen in the CPU, it's 255 times 255 isn't 255. 255 times 255, right, is that number we saw before, 65025. Right? You see what I mean? So every time you do a fixed point operation, you must yourself, right? You must yourself do the multiplication of the denominator, which in this case also comes out to 65025, right? You must do that. And then you, since you are interpreting it as over 255, you must map that denominator back to 255. You must do this equation, 65025, right, divided by what? So we'll just call that x equals 255, right? And you must find that value. And in this case, as you can see, right, that value is going to be 255, right? If you solve for x here, you get x equals 255. Make sense? So yeah, the reason you lose a bit, 65025 divided by 225, is because, oops, sorry, did I just type that right? 6502, I think I did. Yeah. The reason that you lose a bit there, right, is because if I was to actually divide by 255, which is what I want to do, I would have to actually do an integer divide here. I chose not to because the shift is faster. So I shifted down by 8, which actually divides by 256. So dividing by 256 is not the same as dividing by 255, so you lose that 1 bit of precision when you do it that way. So now your recommendation was, why can't you just AND with OXFF? Well, what would that do? Shifting by 8, right, is the same as dividing by 256, which is very close to what I wanted to do, which was divide by 256, I'm sorry, 255. Anding with OXFF is nothing like that. That is mod 256. So rather, if you look at what happens, rather than take, here's our 16-bit value, the color that we want is up here, and there's 8 bits of fractional, right? Because we multiplied 255 by 255, we got the colors up here and we've got a bunch of fractional precision down here that we're trying to throw away. The shift moves the color back into the position we want. The and will just get the fractional precision. So all you're going to get is a fractional precision of how close in between those two values, between the lower color and the higher color, that we can actually represent where you were in there. So an and is exactly the wrong thing here, because we're trying to divide to move our value back into the range. Hopefully that makes some sense. Can you briefly explain how the binary reverse works you implemented last week? It's totally dumb. It doesn't do anything. It's the dumbest possible thing. We literally just have, like, if we have a number like this, we literally just go through, we and out one of the bits, we see if it's 1 or 0, we get that value, and we and it into the opposite position. So we literally just swap bits. That's all it's like the dumbest possible thing. We don't do anything smart there at all, actually. Let me see where that actually is. PNG reverse bits. Where is that? Here it is. This should not be in stream. That should actually be in the PNG reader. Okay. So you can see this right here. We just loop through the bit count, right? We say, look, grab out that bit and let's put it back. We'll flip it to the opposite position. Since we know this is a symmetric operation, let's also just take whatever the bit was in the flipped position and flip that one as well. So basically we swap, right? We read this one and we switch their positions, right? That's all this is doing. This grabs out the two different bits on either side, and this slides them up. You can see these are symmetric, right? We grab the bit that's at bit index and we shove it up to the position that's the opposite of that. And then we grab the bit that's at the position that's the opposite and we put it into the one that we just grabbed, right? So we're just swapping them in. The OR allows us to build up the value periodically. There's probably way smarter ways to reverse the bits than that, I'm guessing. I think we looked some up on stream, but we just don't care. Like we don't care. We only use it for building the Huffman table, so it don't have to be fast. All right, looks like we're all done. Okay. All right. Thank you, everybody, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org. It comes with the source code, so you can follow along with it. And if you want to be up to date on what we're doing at Molly Rocket, including Handmade Hero stuff, you can always drop your email into our mailing list. We finally updated the Handmade Hero webpage, so it's got the mailing list. Sign up on it and subscribe. We send out email only when we've got something to say, so it won't clog up your inbox. That's it for this week. I will be back. I'm sorry, that's it for today. I will be back tomorrow. We are not done for the week. Where we'll finish that stream buffering for the errors, and then we'll try to move the PNG reader into Handmade Hero proper so we can just load that art, and from there we'll start to figure out how we want to do like testing to make sure we can detect when art changes and stuff like that. So we'll be going from there. Again, this is going to be a couple weeks of work for sure, because we kind of are making a whole system for ingesting these art files, but I think it'll be pretty smooth sailing. There's not too much complex stuff in there. It's a pretty straightforward process we're doing. There's just a couple different things we got to touch. So we'll be doing that. Hope to see you back here for that. Until tomorrow, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.